start going over this packet here. When I go through this, you can see the right answers right there. And the answers are also posted, so you might not need the video. I will go through, because a lot of these, have multiple choice options where obviously 4 of them are wrong and 1 of them is correct. I am going to talk through on this video just the one that is correct. Otherwise, this video will end up being like 4 hours long. That said, the reason the other answers are not correct is also very important, and that's where, if you're watching this and me going through the right answer alone didn't help you, like, hey, this one seems right also, like that's when you ask questions in class and say, well, I thought this was right too, go over why this is wrong, or get that cleared up. I'm just explaining that I don't want to make a 7-hour video because no one will watch it, so I'm just going through the right answers. All right, number 1 here. Make sure you realize that it says which of the following is not supported, because I started going through it, I was like, wait, a bunch of these are true, but it ends up being C, because the number who chooses a design with black is not greater than those that chose a design with blue. So black, you would add up these 3 numbers. Blue, you would add up those 3 numbers. Blue comes out bigger, not black, so then, black is not correct. All right, the second one here, they're asking you for here. Well, there's a bunch of stuff. And again, I'm just going to go through the right one because it's just too long to go through all of them. So the median age and the range of ages are both greater for female than for male. So this is a stem and, what is it, a whisker? No. Stem and leaf plant. So here's your stem, and then these are the leaves. And when you read this, it's like this is 20, 20, 21, 22, 26, 27, 29, 32, 33. And on the other side also, like 15, 17, 18, 20, etc. So if I were to just say, like, eyeballing it, where's the middle of this, the center of it, where half of the data is above it and half of it is below? It's probably somewhere in this region. And then here, the middle is probably somewhere in that region. So the median is greater for female because the bigger numbers are toward the top. And then the range is the distance between the biggest and the smallest. So for the female, we got 154 minus 20. So that's 134 spread there. And then for the males, we've got 70 and 15. So the females are definitely more spread out. All right, number 3. So skewed right and skewed left. So it's something like this. Try to put some notes here. Is skewed left. The skew is where the tail is extreme. So normally your normal curve would kind of look like this, and everything's kind of in this nice symmetric bell-shaped deal. Well, when there's a pull to the left, that's called a skew to the left. And then this would be a skew to the right. Skew to the left is also like skewed down to smaller numbers. Skew to the right is skewed up to bigger numbers. So they say in D, they're saying they're both skewed to the left. And it's a little bit goofy because the chart is sideways. But they are both skewed to smaller numbers. So the kind of the main data is in here, this region between like 11, 12, 13. But then you got this tail, so it would kind of go like this. And where's the tail? The tail is the smaller numbers in this case, because the smaller numbers skew. And this stem leaf are at the top, 6, 7, 8, 9, 10. So the majority of data is the bulk of it is here, and then the tail ends up being smaller numbers, and the same thing here. So a typical distribution would kind of look like this. And then what we're doing is grabbing this part here, and it's just getting yanked over there, and it's getting yanked in the direction of smaller numbers, which makes it skew to the left. So D is correct there. 4, which of the following is true? So someone was asking me, these are actual like dots. They look like they're little smudges, and they're not. You're kind of not sure if they're supposed to be there. But they are. So that does matter. And which of the following is true? So again, I'm going to jump to E because it is true. But if you're not sure why one of the elements aren't true, please follow up with me on this. E is right. About half of the males in the sample spent at least as much time as any of the females. So 25% here, 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 and here. 25% here, 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 and here. And you can see that these people, which constitutes 50%, all spent at least as much time in the store. They're all greater than or equal to all of the females. So at least half of the males in the sample spent at least as much time as any of the females, because half of that male box plot is above all of the females. Item 5. So keep in mind that the quartiles split the data into percents of the data. It doesn't mean that it's going to have more data or less data. So there's 25% here, 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 and here, 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 and here. So this gets into like set A contains more data. I have no idea. Then we don't have a list of the data. Set A might be 10 numbers. Set B could be 1,000. They're trying to get you to say because the range is bigger, because it's like a longer whisker, that there's more data, but that's not. Those are not related. The box of set A contains more data. Again, I have no idea how many pieces of data are in these data sets. Set A has a larger range, yes, because that distance is bigger than that distance. So we didn't even get into quartiles. All right, number 6. Again, I'm just going through the correct one. So relative frequencies. Relative frequency is just percent. Grade 11, nope, sorry. D, grade 12 had the least relative frequency of participating students. Yeah, so 10% of 12th graders participated, and that is lower than any other number out there. Number 7, so this is a little goofy, I'm going to have to flip back and forth. Which statement provides the best comparison of the two locations? So what we got, location A, is skewed to the right because there's more spread on the right-hand side. This is skewed to the right, more spread on the right-hand side. I'll be honest, I haven't even looked at the question yet, but I'm just kind of anticipating what they might ask. Remember, you got like your 25% there, 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 and there, and there, there, and there. So let's see what we got. So the answer is C. Compared with location A, the miles driven for location B display more variability. That means more spread. Spread out more. And the median is greater. So is the median greater for B? Yes, it is, because the median is there compared to there. And the variability is greater because that's a lot more spread out than that. Number 8, so this is, again, kind of a goofier one. I got to read this over here, and then I'll slide over to the answers. Golf tournament. Okay, tournament 1, tournament 2, bunch of golfers score. So right away I see like the medians are pretty much the same. Tournament A has a lot more variability or spread than tournament 2. It's got a bigger range than tournament 2. The IQR is bigger. And I haven't even looked at the answers yet. I'm just talking through the graph. So B, in both tournaments, at least half the golfers completed the tournament with a score of less than 288. So 288 is right here. In tournament 1, we got 25% there, 25% there, plus even a little bit more. So yeah, more than half. And then here we got 25% there, 25% there, and plus even a little bit more. So more than half there as well. Number 9. This technically shouldn't even be in this worksheet, so this would not appear in your test because I don't feel like you've been presented with enough with this information yet, but eventually, so I'm going to go through it. So standard deviation is the average distance from the middle. So if you look at data set B, all of these points have a very small average distance from the middle. These ones have a little bigger, but there's just not that many points there that are far away from the middle. And these ones are really far away, but there's still not very many of them. Here's the opposite. This is the middle, but there's not a lot of points that are close to it. And then the further away you get, the more points. So that's going to increase your average distance from the mean. And that's going to increase your standard deviation. Again, that you were not responsible for that this unit, but you will be next. So it's not going to hurt to start talking about it. Number 10. Visits by education, high school, community, blah, blah, blah. Okay. C is the right answer, so I'm going to jump there. the IQR for the number of visits at more than 4-year colleges, the IQR is this distance here, is less than the IQR for the number of visits at community college. So the IQR for community college. So IQR, remember, is your Q3 minus your Q1. It is the size of your box. So they are saying the 4-year college box is smaller than the community college box. And that's your answer. Number 11. So again, we're comparing box plots here. We got regular chips, healthy chips. If I jump to B, the correct answer, the IQR of healthy is greater than the IQR of regular. So again, the IQR is Q3 minus Q1. It is the size of your box. It is that distance. And it is definitely bigger in the healthy chips than it is in the regular. All right, number 12. So we got fertilized and unfertilized trees, and we're looking at height. So again, 25%, 25%, 25%, 25%. This is an outlier. 25, 25, 25, 25. We got some outliers there and one up there. So what are we looking at? Part D is the correct answer. Again, I'm just going to jump there. The median for unfertilized trees is less than the median for fertilized trees. So let's see if that's true. The median for unfertilized is lower than the median for fertilized. Yes. The IQR is greater for the unfertilized. Well, the IQR, again, is the distance of your box, and it is a little bigger in the unfertilized, so D is the correct answer. 13. Let's see. Corn and soybeans, 28 of each. Okay, so I'm gonna jump to the answer. The answer is D, and I would have started with that one, anyways. So let me show you what I mean by that. So if I look at these 28 dots up here, and I gotta find the first quartile, I've got to kind of start crossing off like the top one and the bottom one, and then the top and a bottom, and a top and a bottom, and work my way to the middle, and I'll get to the median. And then I've got to work my way to the middle of, you get like a half, and then you got to do the middle of that half, the middle of that half, and that'll give me the first quartile, the third quartile, and in a quartile range. Well, to do any of those, I got to start doing all the crossing off and worrying about even numbers and odd numbers. So if I'm taking the AP test, I see that, and I'm like, I really hope that's the answer, because I can just look at it and say the corn, biggest minus smallest, is a lot bigger than the soybean, biggest minus smallest. And thankfully, that is the answer, so we can just stop. If that weren't the answer, like if there were soybeans that the range was bigger, this would be a pain. This would be a big pain with my question, because you'd have to start like putting them in order and doing all that stuff. But fortunately, he does not, and I think that's intentional. They don't want you to take 5 minutes on one multiple choice question. 14. So this is just asking you for the IQR. IQR is the size of the box. So that's approximately 20, that's approximately 5. So this distance, I was like, okay, that's about 15. And then the closest one is 16. So that makes good sense. 15, they ask you for the inner quartile range here. So it's not as bad as it seems. There's 100 adult men. So if you've got 100, your median is a little bit goofy. You have to add 1 and then divide by 2. So there's 100 data points. You add 1, 101. Divided by 2 is 50.5. So that means if you find the 50th data point and the 51st data point and average them together, that'll be your median. Right? Well, that would leave 50 data points in the bottom half. So there's like 50 data points here. We got our median, whatever it is. There's 50 data points here. They're asking for the inner quartile range. So I've got to find the median of this half and the median of this half. Well, I'm going to repeat that process. Add 1, divide by 2. 51 divided by 2 is 25.5. So you want to find the 25th and 26th and average them together. Well, these are in order. It's just a little bit different because it's in a histogram. But I'm just going to start counting until I get to the 25th and 26th term. So that's 1. That's another 1, so now I've got 2. That's another 2, so now I've got 4, 6, 9, 13, 18. Is that a 6? 8? That's a 6, so 24. And then 32. So the 25th through 32nd term are in that slot. So that has to be your Q1. So your Q1 is 56. I'm going to do the same thing on the other side, but I'm going to just work backwards. So instead of counting like the 25 up from the bottom, I'm going to count 25 back from the other side. So 1 more is 2, 4, 6, 9, plus 5 is 14, plus 6 is 20, plus 20 is 28. So it's going to be in there. So that is 72. So then 56 minus 72 would get you the interquartile range. And so I get 16. They said which one's the closest, so 15. And yeah. That one's D. I don't know why I didn't put an answer on there. But that one is D. All right, number 16. So what was the price of the last meal you purchased? Interquartile range. Okay. So, all right. Got the answer on the next page. So the interquartile range. So again, I got to kind of work through finding the middle 50% are between what and what. So again, I've got 100 people. So I'm going to find that spot where there's 50 below and 50 above. And that will be 50 plus 1 divided by 2 is the 25.5. So I want the 25th and the 26th number in my list, average those two together. So 8 of them are there, 13 of them are there, now I have 21. Now I have 34. So the 25th and 26th numbers must be in there somewhere. So like between $9 and $11, it looks like. And I don't know exactly what. Some of these might be 9.1. Some of these might be 10.8. I just know that they're between. And then similar from the other side, I want to find 25 in from the back. So 1 plus 2 is 3, plus 5 is 8. This makes 11, 16, 24. So we're going to be looking in here between 15 and 17. So the IQR is going to be what you get when you subtract these, but it's a little bit goofy because it could be like 17 minus 9. Those are your two biggest numbers. So these could all be 17s, and these could all be 9s. And if you did that, 17 minus 9 will give you 8. Or you could, we could be a lot closer. We could be on this end here, which is 15, and this end here, which is 11. So 15 minus 11 is 4. And if you look, okay, I got these wrong. So this D that's down here, this must have been applying to this because the answer to 16 is not D. The answer to 16 is B because that's the only number between 4 and 8. And my range, my IQR has to be between 4 and 8 because of that. So I got some answers to change here. All right, 19. A graph not shown reveals it's skewed to the left. So if I'm skewed to the left, we took what was supposed to be kind of a normal curve, but then took this tail and yanked it out. So it's going to look like this. So you've got like a bunch of stuff here and then some weird stuff in the tail that's going to yank this curved part to the side. Okay, so then if we know that is skewed left, I look at E. E says the value of the max minus the third quartile is less than the value of the first quartile minus the mid. Well, skewed left, and I should put this on the board too. If you're in a distribution curve, it looks like that. If you were in a box plot, it's going to look like that. With this side, I can do a little more extreme version. So it would be more like this. So this side over here, this is going to be your max and your Q3. So the max minus the Q3 is this distance. First quartile minus min is this distance. And so because that's way more spread out, and the reason it's way more spread out is because I know the graph is skewed left. The skew tells you where that spread is. So E is going to be true. And then number 20, which of the following describes a continuous variable? Continuous means all the decimals in between are possible, not just integers. So the number of items, I'm going to go through some wrong ones here too. Number of items sold at a craft booth for one day. Well, you might have sold 2, you might have sold 100, you might have sold 2,000. You did not sell 1.873621. So it's not continuous. Number of apps downloaded from a website. Again, that's going to be an integer. It's going to be 10. It could be a million. It could be 7 trillion. But it's not going to be 7.8. Diameter is a tree trunk. So now we're getting there. So diameter could be any decimal. It could be any, it could be 2.17356, 2.111. So all decimals are possible. Number of baskets made by a player, that's just going to be integers. Shoe sizes, you can get like a 12, 12.5, 13, 13.5. But you can't go to the store and be like, I wear a 1.7362 shoe. I'm going to stop there. So that's your first 20. And I'll make like 3 more.